Here we go. First chunk of stuff that we have that we're going to look at is going all the way back to the beginning of trimester 2 and really the end of trimester 1, okay, where we were talking about linear functions. What makes something a linear function? Do we remember? Holy cow, you have to way rewind. We definitely talked about it.
Oh, yeah.
You said, what do you think?
Has to have a slope and a y-intercept.
Let's just hold on to that thought for a moment, because that's not necessarily a specific linear thing. Okay, what does a linear function look like when we graph it? It's a line. Okay, so we at least got that going. Linear functions make a line. Oh my gosh, my board is off again today.
Miss McKinney, don't you have another teacher that comes in here?
No, not this trimester.
She broke it twice.
It was last trimester with the kids eating napkins.
Yeah, I mean, it's not a new statement to me that my expectations are probably higher than some other people might have. Okay, so we know it's going to be a line. When we look at something, like if we're asked to graph something, how did we say we would know it was quadratic? What made it quadratic?
A, B, and C.
What did A have with it? Ax squared. So what makes something linear?
X to the third. X to the first.
X to the first, right? So this has x to the first with no x squared. Okay, that's telling us that it's linear. Okay, and we said in linear functions, right, there is always the option to create a table, plug in points, find their output values, and plug them on the coordinate plane. Right, that's always an option. But we then said, holy cow, sometimes that's a pain in the butt when there's some shortcuts. Shortcut number 1 is that we could graph in slope-intercept form. And slope-intercept form is the beloved formula of my students. Y equals mx plus b. Right? I like mention slope and they're like, y equals mx plus b. I don't know why. It's the beloved formula. Okay, so y equals mx plus b has 2 things in it that we can find. Yusuf, what are the 2 things in here that we can find? Slope and y-intercept, right? So we know that our slope is m, and we can find our y-intercept, which is b. Bless you. Okay, we also have a shortcut that we can use that is point slope form. Point slope form was our y minus y sub 1 equals m times x minus x sub 1. Do you remember what 2 things we could find in point slope form? A point, right? A point which was an x sub 1 comma y sub 1 and a slope, right? It's called point slope form. Right? It's not very creatively named. Okay, the third shortcut that we said we could use to graph was our ax squared, or ax plus by equals c, which was our standard form. This one's a little bit trickier because it's not given to us in the name. Do you remember the 2 things we could find in standard form?
The x and y intercept.
The x and y intercepts?
I just didn't say it.
Now, my guess, okay, is that we don't all remember everything about all 3 of these forms, and that's okay, Because we also talked about the fact how we could rearrange them and make one form look like another. Right? We could solve for y, we could move the x and y together, right? So that maybe if we didn't remember one form, we could use one of the other forms as an option. So also, just as a reminder, this is the formula sheet, right? Your reference sheet. So if you look on it, right, you'll notice that you see your slope-intercept form, your point-slope form, and your standard forms written on there. Right? It gives you that formula, but it doesn't tell you what two things you find. So that's kind of like, okay, right, I know this is going to make a line because all of these have x to the first power in it. Okay, I know I can use some shortcuts. Okay, so can I look at the reference sheet, kind of remind myself where I'm at, but you're still going to have to put some pieces together on your own. Okay, and I think one of the things that's important to understand, right, often in school, I do it, I know we put you in boxes. We say, today we're learning slope-intercept form. You have to show me that you can use slope-intercept form. But class, if I just say graph something, right, I won't know if Christian decides to solve it for y and someone else decides to cover up and do standard form, right? So you might be doing a different way than a neighbor, and that's okay, because your graph will turn out the same if you did it right. Heck, you might go, I don't remember any of the forms. I have to make a table and plug in input values. That's okay too. Okay, the important piece is that we recognize that this is going to make a line. So let's refresh ourselves on some of these different options here. So what if I said y equals 2/3 x minus 4? What form might we want to graph this with? Slope-intercept, which means we can find a slope and we can find an intercept. So what is our intercept in this one?
-4.
-4. What's our slope?
2/3.
So if we want to graph this, what are we going to do first, Eric?
Plot -4 and then go up.
-4 where?
On the y.
On the y-axis, right? Because it's my y-intercept, so I'm going to plot -4. Then what am I going to do?
Up 2/3.
This is my rise over run, so I'm going to go up 2/3. Right? And I can do that as many times as I want. But there's my line. Let's say you're taking a state test and you're like, oh geez, I forget. I don't know what to do. So I'm going to plug in 0, 1, and 2. 0 times 2/3.
0.
Minus 4. There's your first point. If you plug in 1, what are you going to get out?
2/3.
2/3 minus 4, which is a fraction. If you plug in 2, what are you going to get? 4/3 minus 4, which is a fraction. So let's keep going. Let's plug in 3. 3 times 2/3 ends up being 2 minus 4, which is -2. There's our next point. Oh, there's a line.
Wait, why'd you put that?
Oh, it just gives you a fraction out, and I didn't want to plot a fraction.
Oh, that's why you put the x's.
Right, so this would have been like 2/3 minus 4. So that would have given me a -3 and 1/3. It's not that you can't, you just have to approximate.
Okay.
Right, I just wait until I got to one that was easy to plot. Just because it was easier to plot. Okay, let's say we were asked to graph y minus 4 equals -1/2 times x plus 3. What form would we want to graph this in? Point slope form. Right, Eric, do you see why this is point slope? Because it has this.
Yeah.
Okay. So what does our slope equal on this one?
Would that be -1?
-1/2. Because hopefully one of the things that we all remember is that m is slope. So when you look at your reference sheet, you go, oh yeah, m is in front of the parentheses. So that's -1/2. Okay, you could distribute and solve for y and graph this in a different form. What's our point gonna be on this one?
3.
Ooh, that was good. Someone said -3.
Take like the opposite one.
We take the opposite because remember the rule is whenever the formula has a subtraction sign, it tells us to take the opposite sign of it. Remember, those are the pieces that I say are more important. Whether or not you can spew out a bunch of formulas isn't really the point. You can always Google a formula. You have a reference sheet. It's more important that you know basic things like m is slope. That when there's a subtraction sign in the formula, we take the opposite of it. So this is the point. -3, comma, +4. So -3, +4. What's my slope gonna be? So how do I graph -1/2?
Go down 1. And
Down 1,
Left 2. Right 2.
right 2, because I can only use that -1 time. Right, so -1 over +2. Down 1, right 2. Let's say we want to graph 2x plus 4y equals 12. Right, this is standard form. What do we do to find them in standard form?
divide each other.
We divide, we cover up and we divide, or it's really plugging in 0, right? But 0 always makes it go away. So I'm ignoring this and dividing. So 12 divided by 2 is 6. So my x-intercept is 6. What's my y-intercept going to be? 3. So I'm going to go on my y-axis to +3, and on my x-axis to
+3.
6. Could you have solved that for y and done slope-intercept form instead? Yes. Again, I'm just trying to get some of these sort of back in your head of some of those like basic key pieces. Usually my students recall these better. So I want to see what happens when we look at the next one. So our next one that I have on here is absolute value graphing. Right. How many of us remember absolute value graphing? Ooh, do we have a formula for that on our reference sheet?
Yeah.
Do we?
No.
No.
Oh,
Wasn't this the one that was easier than we thought?
Dang.
Yes, this does tend to be easier than my students think.
This one was.
But let's say, I'm not going to give you anything right now. Let's say this just came up on state testing. Your options are to go click next, leave it blank, or try something. What could we try? What do you think, Christian?
The two options coming out of the bars. That's the negative and a positive.
Okay, so one of the things that we have to remember is that absolute value has this whole negative positive thing going on. Right? When we were solving absolute value equations, we had to consider two options. So does anybody remember what that ends up doing as an effect in the graph? What does the graph look like?
Oh, weird. Like a. Wait, I forget.
It's not a parabola.
1 point negative.
Is it an S?
It's the side thing, right?
Oh, it makes the thing where you have to shade.
Say it again. It's a V.
Yeah.
This is a V-shaped graph.
Oh.
Okay, but that's okay, even if you forgot. I wasn't going to tell you because there's still ways to figure out what it's going to look like. Okay, this isn't something that's on the formula sheet. So that kind of makes it tough because you don't have something you can pull back to on the formula sheet. So maybe we recognize that it's a V. What could we do if we wanted to graph y equals -2 times the absolute value of x minus 3 plus 2.
Switch the negative 3 with the positive.
Okay, so Bailey's saying I'm looking up here at the formula and I see something with needing to change the sign of this. Okay, so we have something with changing a sign, but what do we do with that 3 once we make it positive?
You have to
Remember?
add it to both sides. No, you have to divide.
How about these letters? Do H and K look familiar?
Oh yeah.
Yeah.
What did H and K mean in a quadratic?
X and Y. Right.
It became our,
X and Y. Or
what did that stand for? What's the fancy math word?
Vertex.
Vertex. It's our vertex in an absolute value.
Alright, and then you just plot.
Okay, so what's our vertex here going to be?
Negative 3.
-3, comma, +2. So I'm going to plot the point -3, +2. Then what am I going to do?
Well,
Wait,
we know it's a V.
We do know it's a V.
wouldn't you go?
Oh, let me ask you this. Do we think this V is going to open up like this, or do we think the V is going to open down like this?
Probably
because
down.
the-
Oh,
It's negative.
probably down, because A is negative. So now we got a downward facing V.
You still gotta go down to the left.
This is telling us how many to count. We're going to count down 2 over 1. Down 2 over 1.
Wait, where'd you get that from?
From this number sitting right here in front.
From the A as well.
Uh-huh. Because remember that A is actually kind of more like a slope, more like an M.
Oh yeah.
But just like Christian said, right, we have to do both options of it being negative and positive. So we have to go down to right 1, but we also have to go down to left 1 because an absolute value function is symmetric. Okay, so again, one of the key things I'm hoping you sort of see is like, oh, wait, these things really are connected, right? These aren't really 12 different things that I need to learn. They all have these relationships. They all have these patterns in common. Okay, so let's look at the next one that's up here. What's our vertex now going to be?
Positive 1.
What's our vertex going to be? -1 positive, or -1, -3. That's a subtraction. Because we take the opposite of what, because H had a subtraction sign in the formula. So -1, -3.
This is gonna be an upward facing.
We know it's going to open upwards. So maybe if this was multiple choice, you could at least narrow it down, even if you don't remember other things. Right? You could make a table and plug values in. But what are we going to count now from here?
Up 1 over.
Up 1 over 2. And usually things that my students thought were hard many, many weeks ago, they're like, oh, well, that wasn't a big deal. Right now that we've sort of seen how this is full circle, are we okay there? So far, so good? Okay, let's flip the paper over. What do we got next? Linear inequalities. What makes linear inequalities different than just linear functions?
Shading and local lines.
Shading and solid and dashed. Why? Why do we have all that when we get to inequalities, Olivia?
Because it's like more than and it's not equal.
So when we say something is equal to, x equals 2, how many answers do we have? 1. When I say x is greater than or equal to 2, how many answers do I have? A whole lot more, right? So that shading is representing that whole lot more of solutions. So if I look up here at x, if x is greater than -x plus 3, what am I going to graph first? 3, where?
Y.
On the y-axis, okay. Then what am I going to do?
Why don't you go down?
Go down one, right.
Down one, right one, because my slope is -1, so I'm going down one, right one.
It's a dot.
Okay, so a dashed line. Why is it a dashed line?
It's not, it doesn't have a solid.
Okay, so other than the fact that you've memorized this statement, Mrs. McKinney told me I make a dashed line when it's greater to. Why? Yusuf?
Oh wait, no, I don't
No?
know why, but like I know I'm way to remember.
Why is it a dashed line? Olivia?
Because it's not like exactly 2, it's greater than 2, but that could be like 2.1.
Right, so what's the first number that's greater than 2?
0.00001.
What about 2.000000001?
Yeah, that one.
Yeah.
And 2.0000000000001?
That counts.
Yeah.
Or 2.00000, right? You get the idea, right? So we can get as close to that line as we want, but it's not actually a solution. Okay, so that dashed line says that this is not actually an answer. You can tiptoe up as close as you want to it, but you can't be on it. Okay, then which way are we going to shape?
Down.
No,
Up.
up because
It's up because it's greater.
Greater than means above.
You guys keep confusing.
Less than is lower.
Yeah.
No, I said greater than, y'all confused.
It's okay, it's okay.
calm down, but
This is why we're practicing.
I knew it. Everyone kept trying to have different answers, like I'm confused. Like,
Okay, so you do the next one. I'm gonna be shortly behind you graphing it. You graph it first. And I'll...
yay! Got it. Oh, wait.
We start at -1. And then we go down to right 3. It's a solid line that's shaded below.
I messed up and went double negative.
Right? We kind of remember more than we think, right? This isn't too bad. It's just getting your brain kind of going back there.
Oh no, then we got the quadrant.
Okay, how do we know that these are quadratics?
Says it at the top.
No. How would we know other than that? Squared, ax squared. There's an exponent of 2. Okay, so which one of these is the one where we can just find AH and K and graph from the vertex?
The first one. The second one.
The second one, because this has the parentheses squared. Do you see how this looks almost exactly the same as the absolute value, except instead of the absolute value bars, it has the parentheses?
Yes.
Okay, so what does A equal in this one? 1. What does H equal?
2.
Or positive.
Positive 2. What does K equal? -4. So what's our vertex gonna be? 2, -4. Is this going to open up or is it going to open down? Up, because A is 1. So I'm going to go over 1, up 1. And then I'm going to go over 2, up, over 2, up 4. If I were to go over 3, how many would I go up? 9. Okay, Eric, this might be too old for you, but when you make that name, you sound like Mario when he's doing his long jump in Mario 64 Golden Coins.
What?
Who knows that?
Huh?
I want to know who doesn't know that. Like, if you don't know.
No, he doesn't.
Mario
Yeah, and he was like,
Bros.
ooh, or whatever he does.
Wait. I'm sorry.
When you keep making
I did
your-
something totally. I don't even know what I was. I said up 1, over 1, so I kept going.
Over 1, up 1.
Yeah, 'cause
Over
I
2,
kept
up
going
4.
diagonal. I don't know what I was doing.
It's red coin. By the way.
Huh?
If they're
Wait,
not
so how
called-
many do we?
Yes, they are.
don't we make an
If it's red coins are where you're supposed to go.
No, there's like different goals, objectives for each level.
I know, but
And then when
red-
you meet the
red-
objective, you get a gold coin. One of them is to get the 10 red coins. One of them is to get 100 coins. One of them
You
is to
get
get
a
the different
star
stars.
when you get the coin.
Yes, but it marks it up as like a
Red.
thing in the top. Yes.
So what do we do after the 1?
Yeah, I know, red coin.
After we go over 1, up 1, what do we do after
Then
that?
we go
Over
over
2,
2,
up 4.
and what's 2 squared?
I mean, you can collect the
No,
one.
2 times 2.
Oh, 4.
4.
Oh.
You keep getting square and square root mixed up, and I think that's what confuses you.
Yeah.
It's just the star.
I'm not talking about Mario Odyssey.
I know, but
Super
you
Mario
collect the moons
Bros.
in that one.
Dude, that was the game,
Bro,
bro.
how-
Yes.
That's-
You guys haven't played
original Mario.
Have you guys played the Lost Levels? The one that.
Okay, nope. Last problem. We have one more to graph.
So let's go, boys.
No,
Last
one more. Okay, so what do we do in this one?
Table.
But where do we start?
Quadratic formula.
Negative b over 2a.
Negative b over 2a. So negative 5.
Over.
Good morning, Mrs. McKinney.
Morning.
I am so sorry to interrupt you, and I'm sorry to your class too. But can I speak with Jansen Rollins real quickly in my office?
Yep, I will send him down
And
to
before
you.
you guys ooh, he's not in trouble. I didn't like it.
He'll be down in a minute.
Why is the principal?
Did you see Amara story?
Here, Jansen.
She was playing soccer.
Dude, I know, and he's.
Do you know where you're going?
Yeah.
Okay.
She was trying to get a door.
Okay, so we have negative 5.
She got nails. Like,
No, guys, you're not saying that. Nope. One more.
One more.
Over negative 4. What do we get? Positive 1.25.
Yeah, positive 1.25. Or 1 and 1/4.
Yep, or 1 1/4. I picked this one specifically to do on here because here's one where we really can't avoid the decimals. Okay, even if you choose to say, okay, I'm gonna add 0.75 to go to 2, when you subtract 0.75, that's gonna take you to what? Negative 0.5? Sometimes that just happens. Okay, and it's the reality of the vertex being what it is. Okay, so if we add 1 here, that takes us to 3. This takes us to negative 1.5. What would we then do from there to get all the values?
Plug it into the
Plug it
calculator
into
for
the-
X.
Plug each of them in for x, right? So I'm going to help you out here. Negative 9, 0, 6.125. Oh dear, we did something wrong. What did we do wrong?
Where did we?
Where did my math go wrong?
I don't even know what we did.
The 1 point negative. No.
I'm still trying to think of it.
No, we just subtract the 1.2.
1.25. Somewhere I just did a weird mental math thing, I think. Oh, this is positive 0.5, guys.
Yeah.
Positive 0.5.
Told you.
And then this is a net. Why did you say something like Mrs. McKinney? Your mouth is weird.
Bro.
Dude, come on, good
Come on.
team player.
Oh, now you guys blame him.
You didn't want to say
I
it.
didn't see it.
Even though he was probably sitting there saying it to you the whole time. Okay, so this is a 5. This is a 5. This is a 5.
This 0 is a 5?
This is a negative 0.5.
No, you changed the 0 to a 5, right?
Correct, sorry.
And then
I'm so used to them being negative numbers that I just.